Alright, let's look at number 40. Number 40 says graph and identify the focus and directrix of the parabola with an equation y equals 1/4 x squared. Alright, now we need to put this in standard form. Again, standard form is x minus h squared equals 4p y minus k. So what we need to do is we need to get the x by itself. Right now it's 1/4 x squared, so I need to multiply by 4 on both sides. We get 4y is equal to x squared. So we know that the vertex, the h value of the vertex is going to be at 0. So we can say this is x minus 0 squared equals, now the p value, okay, if you want me to write this opposite, I will, x squared equals 4y, so you can see it in that form. So I know that I got x minus 0 squared equals 4p. Well, 4p equals 4. So I'm going to write that over here because 4p in standard form equals that value right there, the a. Alright, and I keep going. I've got y minus k, well, minus 0. So note the vertex, hk, is at 0, 0. We know that the p value, 4p, in standard form is equal to the a value here, so 4p equals 4. So divide by 4 and we get that p equals 1. So we know that the distance from the vertex to the focus is 1 unit, and then the distance from the vertex to the directrix is 1 unit. Alright, now let's look at our equation. We have a positive equation, so we know that the parabola is going to open upward. The vertex is at 0, 0, that's the minimum. We have a focus that is at, 0, positive 1. And then we have the directrix, which is at y equals negative 1, because both of those are 1 unit away, which is what the p-value tells me. So there's your focus, and there's your directrix. Alright, we're going to skip number 42 because, okay, the way I would do number 42 is I would set up a system of equations from my standard form, right? So this is going to be my x and my y value, right? So I would set up my system of equations. I would say that y 4 equals a x squared, so 0 squared, plus b times 0 plus c. Okay, well now we know that 0 squared is 0, so 0a, 0, 0b, so we know that c is equal to 4. We would set up my equation here, so we would have y 0 equals a x squared, so a 12 squared plus b times x, b times 12 plus c. So this equation would then become 144a plus 12b plus c. And we have our last equation, which again, negative 4y equals a times 0 squared plus b times 0 plus c. Okay, well here's the problem. Negative 4 equals c also. So c equals 4, but c equals negative 4. Okay, so we're going to skip that. Let's go on to number 43. Alright, moving on to number 43. Number 43 says, what is the equation of a parabola with the focus of 6, 8? So we have the focus at 6, 8. We have a directrix at y equals negative 2. Alright, so we know that if I have my focus up here at 8 units, okay, and I have my directrix down here at negative 2, these are both p units away from the vertex. The vertex is going to be at positive 3. This is 5 units away. This is also 5 units away. So 5 equals p. We know that p equals 5. Alright, so now we need to plug it into our standard form. So x minus h squared equals 4p y minus k. We know that the focus, okay, is at 6, 8. Well, the focus and the directrix are on the same axis of symmetry, which also shares the x value of my vertex. So the vertex is going to be at 6, and then we know that the k value is 3. Okay, because again, these are the same x value because the axis of symmetry. And then we know that this is p units away, and this is p units away, so my vertex is at the y value of 3. Alright, so this is h, this is k. We're going to plug it in here, so we have x minus 6 squared equals 4p. We know that p is 5. Y minus 3. Now we're going to put this in y equals form. Alright, so we need to get rid of this 20. The way I get rid of a 20 is to divide by 20. So we have 1 over 20, x minus 6 squared equals y minus 3. Again, we're solving for y, so we're going to move the 3. And we get y equals 1 over 20, x minus 6 squared plus 3. Alright, moving on to number 44. Okay, number 44, it says we have a vertex at 5, 2, and we have a focus at 8, 2. Alright, now let's look at what changed. The y value didn't change here, the x value changed. So this is a parabola that opens horizontally. Okay, so instead of it opening vertically, like we just did up here and finding the p-value is horizontal. No big deal, we're still looking for the change between these two numbers. So we can see that from the vertex to the focus, the p-value was at 5, the vertex was at 5, it went to 8, so the p-value is 3 units away. So now the only thing that changes, guys, is instead of us writing it in this form, we're going to write it in a different form. So instead of it being x minus h squared, it's going to be y minus k squared. Okay, because this is a horizontal parabola. So this is y minus k squared equals 4p x minus h. So that's the only thing that changes. We're still solving it the exact same way. We're still plugging in just like we did up here. We know that the vertex is hk. So we know that we have y minus k, which is 2, squared equals 4 times p, and p is 3, x minus 5. Now we're solving for x. Alright, so let's move our 12 here. We're going to divide by 12. So we have 1/12 y minus 2 squared equals x minus 5. So now to get x by itself, we're going to add 5. And we get x equals 1/12 y minus 2. Sorry, let me erase that and write it better. Y minus 2 squared plus 5. Alright, let's go to number 45, because number 45 is a parabola like you're used to seeing, like we did during our notes for this unit. Alright, so our vertex is at 5, 3, and our focus is at 9, 3. Rock on. So we know that we had a change here of 4 units, so p equals 4. We know that the vertex is hk, so we're plugging it in just like we did up here. So we have x minus h. We know that this is a vertical parabola, so we're going x minus h squared equals 4p y minus k. Let's plug and chug. Rock and roll. X minus h, 5, squared equals 4 times p, which is 4. Y minus 3. So we have x minus 5 squared equals 16 y minus 3. We know that we're trying to get y by itself, so we're going to move the 16 and then we'll add 3. I'm going to do both of those steps at once. So I have y equals, divide by 16, so we have 1/16 x minus 5 squared, and then we move this 3, so plus 3. Alright, let's go down to number 48. Alright, number 48 says, what are the solutions of the quadratic equation? What are the solutions of the quadratic equation? So let me write this down. We have 5x squared plus 17x plus 4. Alright, look at number 48. Again, we're going to find the solutions. So what I'm going to do is I'm going to factor this. Okay, your solutions are your x-intercepts. Okay, so we are looking for our roots. You could easily do the quadratic formula to complete the square. Your possibilities are endless, guys. But I'm going to factor this. We're doing the asterisk method. I put a x in both top parts. Okay, this is a times c up here, so 5 times 14. So I'm looking for factors of 70 that add to give me 17, add to give me b. Those factors are going to go right here. Well, the factors of 70 that add to give me 17 are 7 and 10, right? Both are positive because both of these signs are positive. So we know that we have a positive 7 and a positive 10. Doesn't matter which factor you put where. I'm going to reduce these two fractions. This is divisible by 5, so I'm going to make this x over 2. This is not reducible, so this is x plus 2, and this is 5x plus 7. Alright, now that equals 0, right? So I'm going to set both of these factors equal to 0, so I've got x plus 2 equals 0, so I know x equals negative 2. And I set this equal to 0, 5x plus 7 equals 0, so I know that x equals negative 7 over 5. Okay, I can say that's about 1.4. So those are my two roots, or my two solutions. Let's go on to number 50. Number 50, okay, we're looking at the value that completes the square. So we have x squared plus 16x. So this is b. In order to complete the square, we're going to take b and divide it by 2 and then square that number. So b, which is 16, divided by 2 is 8. We're going to square that and we get 64. So the number 64 would complete that square and make it a perfect square. 52 says solve the quadratic by completing the square. So just like we did, we set that up. Okay, so we're going to set this up. X squared plus 2x minus 4 equals 0. My first step is I'm going to create a blank space, so I need to move that 4 to the other side. I've got x squared plus 2x equals 4. Now, I need to complete the square, right? So I'm looking at that b divided by 2, just like I did up here, which is 1. And I'm going to take that and I'm going to square it. Well, it's still 1. So the completing the square, what I'm going to put in the blank space is a plus 1. Now, I need to do it to both sides, so it's a plus 1 over there also. Here I can complete the square. And I'm going to give you a hint. Whatever you get right here, it's going to be x plus that number when you complete the square. Right? Because x plus 1 squared, if I factor this, it's x plus 1 squared. That's why I just did. I made a perfect square. Bam! There it is. Over here I've got 5. I'm solving for x. Okay, well what do? I square root both sides. Those cancel out, and I get x plus 1 equals the square root of 5. Now when you square root something, you have a positive and a negative solution. I need to move the 1 to the other side, and so I get x equals negative 1 plus or minus the square root of 5. Now again, that's two solutions. That's x equals negative 1 plus the square root of 5, and that's x equals negative 1 minus the square root of 5. You have two different solutions there. Rock and roll. I'm going to go on to number 56. So number 56, we're going to use the quadratic formula, so let's write it down. We got 2x squared plus 9x minus 7. Bam. Okay, so our quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. Alright, this is ax squared plus bx plus c, so we know we're plugging in b. In this case, b is 9, so we have negative 9 plus or minus the square root of 9 squared minus 4 times a, which is 2, times c, which is a negative 7, over 2 times a. Negative 9 plus or minus the square root of 81 minus 8 times negative 7. Okay, sorry, negative 8 times negative 7. Okay, so underneath the radical, I'm just going to go ahead and do that math. We have 81 minus that. It gives me a positive 137 over 4. Alright, so now let's rock and roll. Positive 137. Okay, I'm not about to break that down because it is not reducible. So that is my answer. Now I can say that's negative 9 plus the square root of 137 over 4 and negative 9 minus the square root of 137 over 4. Don't forget you have two different solutions there. That plus or minus means you have two different solutions. Looking at number 58. Number 58 says 9x squared equals negative 8x plus 2. What is the number of real solutions? Okay, what I'm going to do is I'm going to plug this into our quadratic formula, and I'm looking at my discriminant there. Okay, now this is not in standard form. To put it in the standard form, I would have negative 9x squared minus 8x. No, sorry. Can't have a negative a value for your standard form. So let's move this over here. So let's add 8x. Let's subtract 2. So we have 9x squared plus 8x minus 2 equals 0. Now let's plug it into our quadratic formula. So we have negative 8, negative b, plus or minus the square root of b squared. So 64 minus 4 times a times c over 2 times a. So again, all I care about is this piece right here. So I have negative 8 plus or minus the square root of 64 minus 36 times 2, which is 72. So that Okay, 64 minus 72. No, that's a negative 2. Okay, there we go. All right, so negative 4 times negative 2 is going to give me a positive 72. That makes sense. All right, positive 72. So I add those together, I get the square root of 136. Now it's a positive discriminant. If I have a positive discriminant, I get two real solutions. Two real solutions. Okay, if I have a positive discriminant, I get two real solutions. Two real solutions. All right, let's go. Actually, let's stop right there. No, let's go ahead and do number 60. Why not? Okay, it fits with it. All right, so number 60 is negative 7x squared equals 11x minus 4. All right, so again, we want to put this in standard form. I want to move this 7x over here to make it positive. So we have 7x squared plus 11x minus 4. So again, we're looking at the discriminant. The discriminant is b squared, so 121 minus 4ac. So we have the square root of 121 minus 8 times 7. Okay, so again we got 121 minus 8 times 7, because 4 times 4 is, 16. Holy crap, 16 times 7. Yikes. Yikes. So 16 times 7 is 112. So we have 121 minus 112. And again, we still get a positive answer. If my discriminant is positive, we get two real solutions. So we're looking at answer A.